Okay, YouTube, in this video we're going to extend our use of the double angle formulas in order to solve or find the values of the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta when we say know the value of, say cosine of theta or a trig function of a single angle involved with this angle theta. So to find the sine of 2 theta, cosine of 2 theta, and the tangent of 2 theta, we'll go ahead and look at the formulas we have over here and say, well, what is it that we're going to need to know in order to evaluate these? And how can we use what we already know in order to help us find the values that we need to evaluate them. So, for instance, when we see the sine of 2 theta, which is one of the values that we're after here, we know that according to our double angle formula that this is the same thing as 2 sine of theta, cosine of theta. So the idea is going to be this. Well, we already know the cosine of this angle. The one thing we don't know is the sine of this angle. So in order to solve for this, what we're going to have to do is we're going to have to already be familiar with the sine of theta, and we are already familiar with the cosine of theta. So I'm going to go ahead and write this in. We say this is 5 over 13. And we've also been told that this angle theta terminates between 3 pi halves or 2 pi, so it lies in the third quadrant. So how can we use what we already know about cosine to go find sine? Well, we can go sketch this angle. That is, we have some angle that terminates in the third quadrant. So here's our angle theta, somewhere between 3 pi halves and 2 pi. So sketching this in, being already told that the cosine value is 5 over 13, that's the same thing as an x value over the r value for some point on the terminal side. So we know that the x value of this point is 5. We do not know the y value, and we know that the hypotenuse, or the r value here, we say r equals, I'm going to try to squeeze this in here, 13. So since we know that this is 5, we just need to simply solve for the y value here, and we could do that using Pythagoras. That is, if this is y, then we could say, well, x squared, or 5 squared, plus y squared is equal to 13 squared, or 25 plus y squared is 169, or that y squared is equal to 144 when we subtract 25 from this. And so y must be either plus or minus 12, and in this case it has to be a negative 12. And the reason why, no pun intended, is because, well, we're down in the fourth quadrant. So we say, now that I know this, it is fair to say that our sine value, which is y over r, that is how you determine a sine value here, would be equal to negative 12 over 13. So as far as finding the sine of 2 theta's value, we say, well, it's 2 times the sine of theta times the cosine of theta. And in this case, now we know what the sine of theta is, and we know what the cosine of theta is. Our cosine value was 5/13 to begin with, and our sine value is negative 12/13. We were able to find that. So multiplying this straight across, it seems that we get 2 times a negative 12 is negative 24 times a 5 is negative 120, and this is over 13 times 13, which is 169. So this thing right here, this is our exact value of the sine of twice of that angle, 2 times that angle. Okay, so now let's go ahead and pursue our cosine of 2 theta. Now, in terms of which formula to use, I notice that I have 3 choices here, either cosine squared u minus sine squared u, or 2 cosine squared u minus 1, or 1 minus 2 sine squared u. The idea is that we already knew the cosine value going in, so in terms of which one's the most efficient, I would say that using the second formula is probably the best. So we say that this is the same thing as 2 cosine squared of theta minus 1. And so this is 2 times the cosine value squared minus 1, where our cosine value, again, is 5/13. So we're just going to use the order of operations here to simplify this. We have 2 times 25, 169ths. And I'm going to go ahead and find a common denominator here between this and 1, since we're going to be subtracting anyway. So I just changed my 1 into 169 169ths. So we end up with 50 169ths. Subtracting off 169 169ths, and so we end up with a negative excuse me, I think it would be 119 if you took 50 off of this, 169. So here's our cosine of 2 theta. So now the only other thing that we need to determine here is the tangent of 2 theta. And I noticed that the tangent formula requires the knowledge of the tangent of u in the first place. So since we know the sine of u, or sine of theta in this case, and the cosine of theta, we're going to need to find that the tangent of theta in particular would be our sine value, so negative 12, oops, let me rewrite that, negative 12/13 divided by cosine of theta, which is 5/13, and multiplying by the reciprocal we get negative 12/13 times 13/5. and our 13s hit the road, and so we get that our tangent value is negative 12 over 5. Again, we could have just looked at the picture over here also and said it's y over x, negative 12 over 5. Either way, we need to know the tangent of a single u. So now we have the tangent. We were trying to find the tangent of 2 times our angle, which is listed as theta, will be 2 times the tangent of just a theta over 1 minus the tangent squared of theta. So here we have this. We have 2 times our tangent value over 1 minus our tangent value squared. For a tangent value, we were able to determine is negative 12 fifths, negative 12 over 5, or negative 12 fifths. So we have negative 12 fifths in both of these cases here. So, excuse me, simplifying this, we get negative 24 fifths on top. Okay, and on bottom we have 1 minus the square of negative 12 fifths, which is a positive 144 25ths. So we're going to need to deal with this separately. That is, we'll go ahead and find a common denominator in the basement here. I'm going to rip this over here. And so we have negative 24 fifths. That is being divided by 25 25ths, which is a common denominator, with our 1 there. We say minus 144 25ths. So we get all of this over all of this, which becomes negative 24 fifths. I'll go ahead and simplify this here. Over now 25 minus 44 here. Let's see, 24 minus 44 would be 120. So this is negative 119 25ths. And then last but not least, we're going to go ahead and multiply by the reciprocal. So this becomes negative 24 fifths times, 25 over a negative 119. So we get a cross cancellation here at least. So this becomes a 1 and this becomes a 5. So we get now negative 24 times a positive 5 will be a negative 120. And then down here 1 times negative 119 is negative 119. So we end up with a positive tangent to theta value of 120 119ths if I did my mental math calculations correctly here. But that's how we could use the double angle formulas to evaluate for sine, cosine, and tangent of 2 theta given some initial information. We just need to know, say, the sine of the single angle, cosine of the single angle, and tangent of the single angle, which we can always find just by drawing a picture or using fundamental identities. Cheers.